Hello everyone, I am Abhishek HR. Welcome back to the online session on dynamics of machines. In the previous session, you have learnt about the 2-force body member and 3-force body member and also some theoretical concepts of the free body diagram. As you know, you have two types of problems in static force analysis. One is on slider crank mechanism and one more is on 4-bar mechanism. In today's session, I am going to explain about the slider crank mechanism. You all know the construction of slider crank mechanism. Here in this unit, in this type of problem, you are going to analyze the forces on each link and as well as the torque applied on it. So, before going to solve the problem, let us know the procedure about how to solve it and how and what are the steps that we need to follow to solve the problem. Analysis of a slider crank mechanism. Analysis of a slider crank mechanism. You know the construction of slider crank mechanism. So, in the problem, they are going to mention, in the problem, they will give the distance of the links. So, using that distance, you can construct the mechanism or you are going to construct the slider crank mechanism. So, here I am going to construct a slider crank mechanism. So, this is the fixed link . One and one more link, that is crank at an angle of theta . So, this is link 2, this is point A and this is point B. There is a torque on link 2, that is T2. First, I have drawn the fixed link. So, in the problem, they will give the distance. So, based on that, I have to construct the fixed link. Then, this point will be named it as A, and at A, you have to take the angle given in the problem. So, with respect to angle, so since it is a general steps to solve the problem, I will use it as theta. In the problem, they will give the particular angle. So, with respect to that angle, using the distance between A and B, you have to draw the link, that is the crank. This link is a crank. And then the remaining side, that is the connecting rod. And this is the slider portion. And here I am applying some amount of load, that is represented by P, capital letter P, and this link is 3 and this is connecting rod, and this will be C and link is 4. Point A, point B, point C, this is the link 1, link 2, link 3, and here it is the link 4. So, Now I have completed the construction of the slider crank mechanism. So as you all know, link 2 is a crank and link 3 is the connecting rod which is connected to the slider here. So with amount of load, it is going to convert the reciprocating of motion into rotary motion. So all we can say that slider crank mechanism is an arrangement of the mechanical elements that is used to convert the reciprocating of motion into rotary motion of the engine. So with respect to that, I have constructed the slider crank mechanism. So in the problem, they will mention the distance as well as the angle. Using those parameters, you have to construct the slider crank mechanism. So this is our first step. This is step number 1. Construction of the actual mechanism. So in the problem, they will give the a rough sketch and the distances between A and B, B and C, and A and C also. And also they will mention the angle also. Using that, once again you have to construct the mechanism. So that is the first step in analyzing the slider crank mechanism problem. Now, second step is step 2. Now I have finished the construction of the slider crank mechanism. Now the second step is you have to draw the free body diagrams of the slider crank mechanism. You have already learnt about the free body diagrams in the introduction of static force analysis. So with respect to that, here in the second step, you have to draw the free body diagram. So here I have link 2, link 3 as well as link 4. So let's draw the free body diagram. Draw the free body diagram. So this is point A and this is point B, link 2, and here it is torque T2. It is the torque T2, and you have to mention the force also. So this is fixed link, and here the link 2 is connected with the link 3. So with parallel to link BC, link BC. So I have just shown the connection to the link 2. So here you have to show the force also. So as you know, the condition for two force member, what is that? The body should have the equal magnitude but in opposite direction on the same line. So here we have a force, means the force of link is exerting on force on link 2. So it will become F32. F32. F32 means the force of link 3 is exerting on link 2. So it is 3, 2. Force of link 3 is exerting on the link 2, that is F32. This is how you are going to represent the force. And here at point A, so it is F12. F12. Why? Because as per the condition of two force body member, so here the two forces should have equal magnitude but in the opposite direction. So here it is F32 and here it is F12. Now we have link 3. B, and here it is C. This is link 3. Link 3. So the link 3 is connected with link 2 and here the link 4. So here the forces will be here. The force of the link 2 is exerting on link 3 and here the force of the link 4 is exerting on link 3. So it will become F23 and this is F43. This is F23, force 23 at B, and at point C it is F43. So the two forces are acting in a opposite direction on the same line. Next we have the next link, that is 4 at point C. So this is point C and the link 4, point C. This point will be called it as the center point O, 3-force body member in the equilibrium condition. Here we have load, that is P, and the force of the link 3 is exerting on the link 4, so that is F34. Here it is P and this is F14. So this is figure 1 and this is figure 2 and this is figure 3. Now I have finished the second step, that is the free body diagram. With respect to the construction of the slide crank mechanism, I have drawn the free body diagrams of the slide crank mechanism. So here it is link 2 and I have mentioned the different forces acting on the link, each link. So here it is the third link and here it is the fourth one. So in the fourth one we have 3 forces acting at a point in an equilibrium condition. So while solving in the next step, we have to start with the link 4. Why? Because we need to find the different forces on each link as well as the torque applied on it. So here we have the load, means we will know what is the load amount acting on the mechanism. So with respect to, by knowing the load amount, we can find the unknown forces. So that's why I'll start with the next step with link 4. So this is about the step 2. Now I'll moving on to the step 3. Step 3. So here we need to analyze the forces acting on the link. Means here I have drawn the free body diagram and I have shown the forces. What are the forces acting on the links? Now I need to find those forces. So I'll start with the link 4. So here Consider link 4. Consider link 4. So here we have three forces. One is P, one more is F34, and one more is F4. With respect to this, I have to construct the polygon. Construct a polygon with respect to link 4. Link 4, because we'll know the value of the load, so that with respect to the load we can convert into the scale. So with respect to scale, convert the load value with respect to scale to construct a polygon. So using the load value, because they will give the load value in the problem statement itself. So using that load value, I will start the construction of polygon. So here, for example, it may be 100 Newton, 200 Newton, like that. So by using that 100 Newton, I'll convert the scale, like 1 centimeter is equal to so and so, like that. So with respect to that, the load is acting in the x-axis, right, in a straight line. So draw a line parallel to the load, actual load on the mechanism with respect to the converted scale. Let us call this point as OA. This is what? The P. So for the converted scale, I have drawn a line parallel to the load which is acting on the mechanism. Now I have the one more link here, that is F34, means the forces of link 3 is exerting on the link 4, that is the F34. So parallel to F34 or the line BC, draw a line, because I don't know the exact distance value or any other value regarding the F34. So I'll just draw a straight line parallel to F34 or the BC line. So just draw a line, straight line. Just draw a straight line parallel to BC, because while constructing the mechanism, you have to start from the top page of your notebook, and from with respect to BC, measure the distance, or put your scale on the BC line and just pull down your scale, and with respect to that draw a line parallel to BC. Now I have the straight line, that is F14. From point O, just draw a line, straight line, perpendicular line. So this point will be B, point B. So this is what? This is the F34, and this is what? F14. So this is the polygon. So I have constructed the polygon. Here I know the value of load, so just draw a line OA with respect to load P, then draw a line OB parallel to BC or the link 3. Then draw a perpendicular line to the OA to the OA at B. So these are the steps that you need to follow to construct the polygon. Just take the load value, convert it to the scale, take that scale, draw a straight line with respect to the load on the mechanism and name it as point O and point A. Next, at point A, parallel to BC, that is link 3, draw a straight line. Because I don't know the exact value what it is, just draw a parallel line, and then I have the one more force, that is F14, that is acting perpendicular to the load. So just at point B, draw a straight line which will meet the point O, so that we will get a perpendicular line to the load, so that it will complete the polygon. Now from this, measure the distance AB. So AB is what? F34. Then OB will give F14. So measure this distance, multiply with your scale, so that you will get the force value of this AB, that is F34. The force of the link 3 is exerting on the link 4, as well as the force of the link 1 is exerting on the link 4. So you will get the required forces. Now this is only the F34 and F14, but as per the conditions of two force member, we know that. So next step 2, step 3, next step 4, analyze the forces. See here, at B, here I have F32. So that F32 is nothing but the force of the link 3 is exerting on link 2, as well as it is also indicates that the force of the link 2 is going to exert on link 3 also. That is nothing but F32 is equal to F23. Because the equal magnitude, it is two possible cases. One is the link of the force 3 is exert on link 2, and also the force of the link 2 is exerting on the link 3. So that is why F32 is equal to F23. So then here also, if it is F23, I have already written, so that will be equal to F32 also. And here F34 is equal to F34, means the force of the link 3 is exerting on link 4. So F34 is equal to F43. F34 is equal to F43. So just mention the values, whatever the values that we will get from the construction of polygon. So from this, we will get the force values, that is F12 is equal to F23, F23 is equal to F32, F32 is equal to F43, that is equal to F43, and also so this is how you will get the magnitude of the forces in each link. So if you measure this F34, so you can get the other forces on the link also. Along with that, we'll also get the F14 magnitude also. So this is about the fourth step. Now coming to the step 5. So this is the last step and also the important step in the mechanism. Here you are going to find the required torque value applied on the link 2. So with respect to the link 2, because in the step 3 I have considered link 4, then in the next step, that is step 4, I have analyzed the forces on the link 3 also, the different forces, possible forces acting on the link 3. Then now I will moving on to the link 2. So parallel to link 2, that is AB, so draw this once again. So use the given distance and also the angle, required angle, and parallel to that draw a line. Now for the link 2, one more link is attached, that is link 3, and as well as the F12, force F12. So parallel to that draw a line F32 as well as the F12. F12, this is F32. Why? Because in the opposite direction of the two force member. So just extend this line, and take your protractor, put it on the straight line here, measure the 90-degree mark. Make a point on this line and put your protractor on that point and mark the 90-degree. Then draw a straight line with respect to 90-degree. Draw a straight line. So you will get a straight line here. So this is the 90-degree. Measure this distance. This is nothing but the height of the link. So to find the torque value, so that is nothing but T is equal to force into distance. So here T2 is equal to, what is the force here? F32. You can take any force, F32, F34, F43. So F32 into the height, the distance of the link height. So it will give the torque value in Newton meter. So this is the final required value, that is the torque applied on the link 2, that will be Newton meter. Why? Because force is in Newton, distance is in meter, so it will become Newton meter. So this is how we are going to carry the process or the steps to analyze the different forces on the link as well as the torque applied on the link. Now I will just repeat once again the overall steps that will be used to solve the static force analysis of the slider crank mechanism. So the very first step is construction of the actual mechanism, because in the problem they will give the different dimensions and the angle and also the load. So with respect to that, we have to construct the slider crank mechanism once again, and also we need to show the different links and the angle also. Next, in step 2, draw the free body diagram, means of the individual links, draw the free body diagrams. So on first figure 1 I have drawn link 2, so that will be connected with the F32 and F12. I have already explained about how we are going to choose the forces. If it is F32 means the forces of the link 3 is exerting on link 2. So that is what F32. So here it will become F12. And in the figure 2, that is the link 3. So here it is F23 means the force of the link 2 is exerting on the link 3. Here it will become F43. Then in the link 4 we have 3 forces acting at a point under equilibrium condition. One is load, applied load, one more is F34, that is link 3, and one more is F14. So these are the free body diagrams. And here step 3, I have to start with the link 4. Why? Because by knowing the known value, we have to find the unknown values. So I am going to construct the polygon by using the load value, convert the load value into required scale, and draw a line with respect to that scale value parallel to the applied load on the mechanism. So it is a straight line towards left hand side. So I have drawn the OA line. Next, at point A, I have F34. So parallel to this, just draw a straight line. Then I have F14. It is perpendicular to the load. So just draw a straight line. So you will get a meeting point of 2 line of action of forces, that is F34 and the F14. So measure this distance A and B, that is F34, and also the distance O and B, that is F14. So from this you will get the forces of the AB and also the OB. So the steps that you need to follow is draw a line OA with respect to P, means the load value. Then draw a line OB parallel to BC. Then draw a perpendicular line to the OA at B. So next, analyze the different forces. As per the two force member condition, F32 is equal to F23. So F34 is equal to F43. Why? Because there are two possible cases. One is the link 3, the force of the link 3 exerting on link 2, as well as the force of the link 2 is exerting on the link 3 also. So with respect to that, we will get the forces F12 is equal to F23, F23 is equal to F32, F32 is equal to F34, F34 is equal to F43. So mention the measured magnitude value from the polygon. Now step 5, the final step. In the final step, once again you are going to construct the link 2 with respect to the given dimension, and just extend the line here or the top at the point B or at the point A also, and using your protractor mark the 90° and draw a straight line and measure the distance from A and B, that straight line. So you will get the height, the distance value. So as we know, so torque, that is equal to force into distance. Here force is what? F32 into height, the measured value. So you will get the torque in Newton meter. So this is all about the steps or the process we are going to follow while analyzing the static forces of the slider crank mechanism. In the next class, we are going to solve the problem on slider crank mechanism.